Thank you, Brian, and good afternoon. Um, I don't, I don't know. I don't like to worry about big fancy titles, but I'm an engineer at Google. I lead part of our team around supply chain integrity for open source. Um, I wanted to spend a few minutes to talk to you about what is Sigstore. It's a fast-growing project. It was nice to see a few hoodies out in the audience already of wearing the Sigstore logo. I thought about bringing mine, but had enough stuff in the luggage. But I'll take you through kind of some of the motivation behind why we created the project, just a quick high-level view of the architecture, what are some of the moving pieces, and some of the wins that we've had in terms of overall adoption over the past several months I guess it's been about 2 years now since we started it. But hopefully if you're sitting in the room today, this chart, you've probably seen this up and to the right graph of, unfortunately, a rise in supply chain attacks. This comes from the Sonatype State of the Software Supply Chain report. If you haven't taken a look at that, I highly recommend it. It goes into great depth in terms of some of the nuance and challenge that exists in the ecosystem today. But the long story short is this is not an up and to the right graph that you want to show an executive. This is unfortunate and to the state of much of upstream today. There are certainly spots where we see projects doing the right things and that are not largely vulnerable to many attacks, but unfortunately those are the exceptions to the rule today. And so events like SolarWinds or CodeCov or Trojan Source, I know David mentioned typo squatting as another type of attack. This isn't the last of these attacks, and we're going to see many more, unfortunately, in the months to come. So you've seen the industry rise to say, how do we solve this problem? And so a lot of where the conversation in the upstream today is around, let's generate better information about what is the state of the supply chain. So you see a lot of conversation around SBOMs. Let's create SBOMs, and once we have them, we'll be good, right? It helps, but it's not necessarily everything. Build provenance, understanding what were the inputs to the build, what were the outputs from the build, and how do we ultimately get a trusted document that says this is the exact sequence of steps that were taken. That would be very useful in a lot of cases to understand where the possible opportunities for tampering, and hopefully there aren't any. But that would be super helpful to have that documented. We have the artifacts themselves, obviously widely available, vulnerability scanners. We have no shortage of those today. But we're quickly evolving in the industry towards having lots of information about the supply chain. We need to be able to trust each of these documents. And so digital signatures are a technology that allows you to bind cryptographic information with identity information and put that together to say, well, for a given artifact, this person is making a statement that this is what they saw at a given point in time. And if you choose to trust the author of that digital signature, then that obviously goes towards your overall trust decision around whether I should use that artifact in an environment or not. So we want to see all of these data sources, all of these signals, as I call them sometimes. We want them to exist, but we want them to be digitally signed as well, so that we can understand that relation around who generated them, or who's making this attestation about their quality, and ultimately rise that up into a higher level policy decision. So I'm not here to tell you that Sigstore is a fundamentally new crypto algorithm or a nice new Web3 token NFT thing. It's none of that. It's the same digital signature technology that has existed on the public internet for the last couple decades. The problem is that not many people in the upstream are actually using them. And if you really dig into that and you say why, there's two fundamental challenges that frequently pop up. One is around the developer experience. I would ask for you to raise your hand and say, have you ever tried to use PGP? But in general, I know how this sort of thing goes. Everybody kind of goes, I tried once and it was hard, or I didn't understand it. Some projects do use PGP successfully, but the developer experience leaves quite a bit to be desired. It's complicated. You want to make sure that you're doing something like this correctly, but the experience is not that great. The second problem, if you want to go down this path, is that you have to have the cryptographic key material. And if I'm going to generate those keys, I have to share my public key with others. Well, how do I do that, right? In the pre-COVID times, like you would have web of trust key signing parties, and you would verify somebody's physical ID with their PGP fingerprint, and you could get a sense as to, okay, I know this person. Well, post-COVID, that's not happening anymore. Second is storing the private key and making sure that only I have access to the private key. In the kind of the existing paradigms, you would generate a key once and you would use it for 10 years, 20 years, 30 years, which is fine as long as you can keep it secure for that long. But what we've seen in the industry is a massive shift towards short-lived tokens and short-lived key material, which helps to drive the challenges with storing that key material down quite a bit. But finally, key compromise does happen, unfortunately. And the question is not how do you prevent it from ever happening, but frankly, if it does happen, how do I respond? And so when people look at this overall challenge with dealing with the cryptographic keys, it tends to shy a lot of people away from using digital signatures. So, let's presume that you're comfortable with managing keys and you understand the technology. This notion of identity is also a fundamental concept within digital signatures. And when you think about this as an example of installing a Helm chart and then looking at the pods that make up that particular deployment, well, what's the identity of this container that I'm using, right? It goes down to the base image that was created from, there's the identity of the repository itself, where do I pull the signature from, who are the maintainers of the dependencies, and what happens if I don't have perfect information about all of these? Well, was it the individual developer that signed the container, or was it the build system that signed the container? This problem gets very, very complex very, very quickly around choosing what do you fundamentally trust. Well, the good news is that we have evolved as an industry and evolved as an upstream ecosystem over the past several years. And so these are just 6 trends that Sigstore really has taken advantage of and helped to bring together as we've built a solution that I'll talk to you here in a second about. But I do want to spend a minute just to go through these 6 because they are really the fundamental components that help make Sigstore what it is today. So starting on the left, we have workload identity. This is the ability for build systems themselves to act as signers and have identity that is independently verifiable. So we've seen projects come out of the CNCF like Spiffy and Spire that actually make it much easier for workloads being spun up to get key material and identify it in a useful way. Moving clockwise, we've seen the OpenID Connect protocol become proliferated across the internet. So whenever you go to a website and you say, I want to log in with Google or log in with Facebook or log in with Twitter, you're using the OpenID Connect protocol to securely attest to your identity without actually sharing the credentials, your username and password with the website that you're trying to access. Sigstore uses that same underlying technology around OpenID Connect to help share identity information between the developer or workload and the signing service. But we need to do that in a privacy-conscious way. And so we've seen the rise of many new techniques within the confidential computing space as well that we're starting to embrace. But all of that's great. Let's say that we digitally sign an artifact. And David, I'll just pick on him. David signs an artifact, and he wants to give it to somebody. Well, what happens if I steal David's key, I sign an artifact with malware in it, and I hand it to somebody else? It's that same person. Well, how do I know which one is true? Transparency logs offer a way to have a shared ledger that stores all of the information around a particular use case. In this case with signatures, we're storing signatures inside of a transparency log. And what this does is it mitigates a particular type of attack called a split view attack, where a bad actor might be giving you a one-off build signed with somebody's keys with malware or some nefarious code in it. When in reality, if you were to be able to go look at a global database and say, well, wait a minute, this isn't published in the database, I shouldn't trust it, even if it's signed with David's key, if I'm not willing to attest to that publicly, that's probably a decent sign that there's something going on here that should raise a red flag. And then finally, kind of completing the circle, we've also seen a rise of automation around certificate authorities and making it much easier to get certificates. Largely this has happened in the SSL or the TLS space, but we're starting to see that adapt more widely. And then finally, with projects like the Update Framework, which is a graduated CNCF project, we're actually able to deal with the end-to-end management of distributing artifacts as well as with their cryptographic material down to a consumer that mitigates a variety of threats. And that project has kind of grown up over the past several years and now getting wider spread use in the industry. So all of these things kind of came together at the perfect time, and with the Sigstore community, we said, our mission is what Let's Encrypt did for the TLS certificate ecosystem, we want to do that for software signing or artifact signing in general. And what does that really break down into meaning? 3 things. Number one, we want that process of getting digital signatures and verifying them to be as easy as possible. We want it to be free, we want it to be simple, and we want it to be intuitive so that people actually take advantage of the technology. Second, we want to make sure that it's widely used everywhere, and part of that is through automation. So we need to leverage these trends around certificate of authority automation and the ACME protocols. We want to make sure that those are actually brought forward in this project to make sure that this system is widely used. And that kind of gets to the last bullet point, is we want digital signatures to be used everywhere throughout the software supply chain. They don't solve every single attack under the sun. You can still sign things with malware, but if we aren't using digital signatures as a predominant tool in our toolbox, then we're really missing an opportunity to mitigate a large variety of threats that exist today. So, very long-winded way of saying, all right, what is Sigstore? So Sigstore is a way to pull together many of these different technologies to make it easy to use digital signatures. But Sigstore itself is very much an umbrella term. It's a set of projects that have evolved and that are a part of the OpenSSF. It's also a set of services that are freely available to individual developers or systems out on the web, and it also refers to a community. So I'll go through each of these in a little bit of detail. So the projects, there are different categories of projects. We have two major server-side components. One is a transparency log that I talked about before, and the second is a certificate authority. The other class of projects we have are really around the clients. Again, we want to make digital signatures easy to use. And when you go and you approach a Java community and you say, hey, we would love to see digital signatures used more aggressively in the Java ecosystem, they go, great, how do we do that? And if you go, here's a Golang binary that solves all your problems, the conversation doesn't go much farther than that, right? Clients want native tooling in their native language ecosystems to make it simple and easy and idiomatic for them to use. So part of what Sigstore is doing is we are doing the hard work to make sure that we have consistent logic across many of these different programming languages to make sure that the best practices, as David alluded to, are pulled together and are actually independently verified across what works in Ruby, works in Rust, and what works in Rust works in Python, et cetera, et cetera. And part of that also goes to other supporting projects where we want to make sure that these signatures are being verified and useful in environments. So one of the things that you'll hear about later from an ex-colleague of mine from IBM is the use of verifying Sigstore signatures as part of a broader framework within a Kubernetes deployment. So we have a couple projects that are supportive of that work, but you'll get into more detail with that. On the services side, as I mentioned, part of our goal is to remove all of the friction. And if you look at the existing code signing ecosystem today, you can get a code signing certificate by paying hundreds of dollars to a vendor. And for a lot of the open source community members that are out there, the maintainers that are out there, they don't necessarily have the means to spend that money to get a code signing certificate. Not to mention they don't know how to or don't want to store a key material. So we wanted to stand up instances of our Sigstore services available for free for the public good. But we also want to recognize that those services may not meet every single use case. So we do have the ability for end customers or individuals on the web to run instances of these projects themselves within their own environment. They don't have to use our public instances if they don't choose to. So we want to be very open and interoperable with different environments and different frameworks as we go to deploy this out. But for our public instances, we want them to be run by the community because it's important that they are vendor neutral, that it's not like, oh, well, I'm using Google for this, or I'm using Meta for that, or Amazon for this. People fundamentally trust neutral instances, and that's what we've learned from the experience with Let's Encrypt and the ISRG that runs a lot of that infrastructure. So we wanted to do something very similar with Sigstore. So we have a multi-vendor SRE team that's, we're running it on, best of breed cloud infrastructure. We're managing SLOs. We've got GitOps infrastructure behind it. I can tell you the pagers did wake me up at 3 a.m. this morning for an issue, so they actually are working. And we did have a team that responded very quickly to a very minor issue. But in general, we have that multi-vendor team that's been pulled together to run that for the good of the ecosystem. And then finally, we're part of the OpenSSF. Obviously, I'm here today, but we have the support of the foundation in helping to to bring forward many of these projects together around many of these different ecosystems. So we get a lot of support and we have a lot of engagement. We're one of the top 25 largest Linux Foundation projects, and we were really only about 2 years old now. So it's been just a massive growth and interest across the entire community. So we have regular meetings, regular office hours. We're introducing the concepts of SIGs that people can come and engage in the community in different areas where they might be specifically interested. And so over those 2 years, Sigstore has luckily started to become more widely adopted across the supply chain. So just a couple examples here. This is a bit of just a logo chart. The couple that I'll call out here are the open source communities. So we've seen the NPM community. So this is the JavaScript, the largest programming language on the planet, has published a request for comments draft to their community saying that they are going to not only use Sigstore to sign their artifacts, but they're also going to use it to sign build provenance that are going to be coming out of their cloud-hosted systems. We have the Python community that has started to sign their releases of the actual Python interpreter with Sigstore. And so if you go to python.org right now, you can actually see the verification instructions that come along with using Sigstore as part of that. And then finally, we have the Maven Central group that's largely funded out of Sonatype, but it is an open effort that has been aggressive to help adopt Sigstore technology for the Java ecosystem. And so there are some recent presentations that you can find on YouTube that go into much greater detail around how we're working with the Java community to actually replace PGP and become the primary source of use of digital signatures within the Java ecosystem. So we're talking about major programming languages that have analyzed this approach that we have bought into it, and we're starting to see signatures rolled out as part of their major releases. So that's all amazing. To quickly go technical for a second, I mentioned these kind of 3 different components: the transparency log, the certificate authority, and then our tooling. The workflow, essentially, if you're a developer or a workload, goes something like this. You'll launch a utility in your language of choice to essentially say, I'd like to make a signature. And I either have access to key material through KMS or through access to a hardware security module, or maybe I don't want to actually deal with that at all and I just need some very short-lived keys. And so that client utility, which we refer to here as cosign, let's see if my laser works here, will ultimately deal with the interaction with the other parts of the system and hopefully make that experience very easy and simple so that you understand what's going on. Once you generate, you have the artifact that you want to sign, you need to go talk to the code signing certificate authority. And this is, again, is what binds the identity of a workload or the identity of a developer with the key material, so that when I go back to verify, I understand that linkage as part of my overall trust model. And then finally, once I actually sign the artifact, I need to go put it inside of this transparency log. And so end users, once they are verifying signatures, they also need to verify that the signature is included in the log so that they have that assurance that they're not vulnerable to a split view attack. So these are the major moving pieces. Cosign is probably our most popular client at this point, but again, we do have support for Python and Java and Rust and Ruby and many of the other major ecosystems as well. From an operating mode perspective, I also mentioned briefly before that you can use our public instances, but you're not required to. So if you're more comfortable running your own infrastructure because you have your own internal identity systems that you want to integrate with, that's great. Sigstore totally supports that. If you happen to work in a highly regulated environment and you need to run in what's called an air-gapped or a completely disconnected mode, we actually have support for doing verification of our signatures in that mode, which is awesome. And then finally, we do interoperate with the existing key management practices that are out there around hardware security modules or key management services from clouds, but also have this nice, what we call keyless model, akin to the serverless model, where we can dynamically generate keys, use them for a matter of seconds, put them onto the log so that they're persisted forever, and then actually delete them from memory so that we don't have to worry about the compromise of a private key. And so we have a very flexible deployment model where we can interoperate in a variety of different situations, which is really why Sigstore has emerged as popular as it has. So in closing, what I would encourage you to do is learn more about Sigstore. We have a presentation coming up shortly which will help with that. But ultimately, we are a fast-growing community with starting to see a much greater set of projects and ecosystems adopt us. It doesn't matter whether you're not a Golang programmer. We actually have work in many different languages where you can come and get engaged and get involved. Our community is also very diverse. We have folks engaged from academia. We have master's and PhD students that are contributing. We have many different large corporations and small corporations that are ultimately contributing in this community. And we are really having a big impact out there today, as evidenced by the work within the Kubernetes ecosystem, the Python ecosystem, et cetera. So we point you to our website. We have documentation. We have a Slack channel. We have a blog with regular updates. So all of those are available for you to learn more about what we're doing with Sigstore. But with that, thank you for the time, and hope you enjoy the rest of your day.